Evaluate the series as n go from 0 to infinity, 5 to the negative n. We recognize that this is a geometric series by rewriting this as the series as n go from 0 to infinity of 1 over 5 to the n power, or the series n equals 0 to infinity of 1 over 5 to the n. This is the series of the form ar to the n with a equals 1 and the ratio 1/5, which is less than 1. The absolute value of 1/5 is less than 1, so we can use the formula for the geometric series, which states that in a geometric series, if the absolute value of the ratio is less than 1, then the series converges to the sum a over 1 minus r, where a is 1 and r is 1/5. So this series converges to 1 over 1 minus 1/5, which is 1 over 4/5, or 5 over 4. This is the sum of an infinite convergent geometric series. For the series at n go from 3 to infinity of 7 times negative 3 over 4 raised to the nth power, this is a geometric series ar to the n with a equals 7 and the ratio is negative 3 over 4. The absolute value of the ratio is positive 3 over 4, which is less than 1, so the geometric series converges. And if it is convergent, then we can find the sum. However, in this case, the series start with n equals 3. There are a few ways to do this. If we remember the formula, we simply use it, or we can rewrite this series at n equals 3 to infinity of 7 times negative 3 over 4 to the n equals the series n go from 0 to infinity of 7 times negative 3 over 4 to the n power, but then we borrow a few terms so that we can start the index with 0. We have to take away those. First, we don't have 7 times negative 3 over 4 to the 0 power. Next, we don't have 7 times negative 3 over 4 to the 1 power. Next, we don't have 7 times negative 3 over 4 to the 2 power, so we need to take away these. Now that we have a series that starts with 0 and the ratio is negative 3 over 4, its absolute value is less than 1, the geometric sum is a over 1 minus r, where r is negative 3 over 4. And we still need to take away these as well. We factor out 7 inside the bracket. Negative 3 over 4 to the 0 power is 1. Negative 3 over 4 to the 1 power is negative 3 over 4. And negative 3 over 4 squared is positive 9 over 16. We then simplify this expression. 7 over 1 minus negative 3 over 4 is 7 over 1 plus 3 over 4. Minus 7 times 1 minus 3 over 4 plus 9 over 16 is 13 over 16. This is 7 over 1 plus 3 over 4 is 7 over 4. Minus 7 times 13 over 16 is 91 over 16. This is 4 minus 91 over 16. Simplifying this, we will have negative 27 over 16. For the series, as n go from 0 to infinity of 2 plus 3 to the n power over 5 to the n. At first, this might not look like a geometric series, but if we rewrite it as the series and go from 0 to infinity of 2 over 5 to the n plus 3 to the n over 5 to the n. Since series had linearity properties, we can separate the sum into two sums. 2 over 5 to the n, one sum and the other sum, and go from 0 to infinity of 3 to the n over 5 to the n. We still need to rewrite each of these sums so that the geometric form shows up. The first sum and go from 0 to infinity. We factor out the 2, then we have the ratio 1 over 5 to the n. For the second sum, the initial term is simply 1, and the ratio is 3 over 5 to the n. Each one of these has the ratio less than 1, so we can find the sum using the formula for the infinite sum since n start with 0. For the first sum, it is a over 1 minus r. r is 1/5. And for the second sum, a is 1 and the denominator is 1 minus r. r is 3/5. Simplifying this, we have 2 over 1 minus 1/5 is 4/5. And for the second term, 1 over 1 minus 3/5 is 2/5. This is 2 times 5 over 4, which is 5 over 2. And the second one is also 5 over 2 because of the reciprocal. So the answer is 10 over 2, or simply 5. For the series at n go from 1 to infinity, e to the n power, this is a geometric series with ar to the n, where a is 1 and r is e. And since the absolute value of r is more than 1, this series diverges, so there is no sum here.